Our castaway today is Professor of Chemistry and Biochemistry at the University of Bristol, Professor Dek Woolfson. He is Director of BrisSynBio, a synthetic biology research centre, as well as Joint Chair in Chemistry and Biochemistry at Bristol University. So welcome, Professor Dek Woolfson.
Hello Alice, thanks for having me on.
You are currently Director of BrisSynBio, a synthetic biology research centre. What does this involve?
So the job started actually quite a few years ago when we were trying to get together people at Bristol that were interested in synthetic biology to try and create like an internal network. And that worked quite well, and we got a bit of money to spread that network nationally, and we involved people at Oxford and at Leeds and at Cardiff. So that was a national mini network in synthetic biology. There were several of those around the country at the time. This was about almost 10 years ago now. And then about 3 or 4 years ago, the research councils, encouraged by the government with some funding, put out a call for applications for synthetic biology research centres. And we applied, and I was pushed forward as the lead principal investigator on that. So I coordinated the writing of that proposal. And now that's transformed into me being the director of the centre. So what I do, I kind of split my time about 1/3 to the centre, 1/3 admin and stuff, and about 1/3 on my research group. So I probably spend about 3 mornings a week doing work on the centre, and that can involve anything from fighting fires, a piece of equipment has broken, where do we find the money to replace that or fix it? And then lots of fun things, like we've appointed 2 fellows in synthetic biology, and I was involved in putting the case forward for getting those people here and interviewing them and helping them establish their labs. That's kind of fun. And also engaging with our what's called scientific advisory board. So these are international dignitaries, big wigs in science, both academic and industrial scientists. And they come here once a year and they assess what we do. They advise on what we do. And I host them and help coordinate the visit. But of course, it's not just me. I'm the director, but there's a whole bunch of scientists behind it, involved in about 12 to 15 scientific projects. And there's also a fantastic admin team that basically do everything. So I'm the front man. I'm the figurehead at the front. But there's a lot of brilliant people behind me doing all the work.
So can you give some examples of the projects they're working on?
Yeah, we've got a whole load. We've got one guy that's trying to manipulate wheat with CRISPR technology, that's genome editing, to try and make to try and get new strains of wheat more quickly so that you can select things that have got higher yields per hectare of crop that you're growing. That's one. And we've got a fantastic set of people between chemistry and biochemistry that are involved in trying to turn E. coli into drug factories. So can you make E. coli make drugs, right, and discover new drugs? That's one thing. So that's bacteria to produce drugs. My own research group's interested in how we can turn some of our protein assembly work that we've done into a biotechnology that makes new virus-like particles that can make vaccines, that can substitute as vaccines. So we're trying to make vaccines, basically. And there's a whole load of other stuff going on. Those are the 3 I've just given are the more applied areas, but we also have people that are interested in everything from the origin of life through to how you manipulate living things. So we've got one group of biochemists and engineers that are trying to get different bacteria to communicate with each other and pass messages and information between each other. So there's a whole range of stuff we do in the centre. It's kind of fun.
So we're here today to find out about your views surrounding synthetic biology, but also to hear about the items you've picked to take with you on the desert island.
Yes.
On the island, you already have a copy of the iGEM registry with access to all the synthetic biology parts and a solar-powered bento lab, but you are able to select one other book, one other piece of science equipment, one luxury item and 2 songs. So tell us about the first song.
The first song has got to be Depeche Mode, Just Can't Get Enough.
And why did you pick this song?
A whole load of reasons. I think One of my nicknames at school and early on in my career at university was Tigger. I had lots of energy, and this song has got lots of energy. For my sins, I was a neuromantic when I was growing up in the 80s and going through college, and it was one of the first songs I ever bought. And I can remember dancing like crazy at university on the dance floor in a very sweaty subterranean disco, just going absolutely mad with friends.
You also give lectures at Bristol University on a number of topics, including synthetic biology. A large part of our iGEM project is human practices, where we take our project beyond the lab, and one of our aims is to create a synthetic biology module for students at Exeter University. If you could pick only one fundamental learning objective that needs to be included, what would it be?
Oh, wow, that's right on the spot, isn't it? Put me right on the spot. That's a real toughie. Do you know what? I'm going to be really biased, and I'm going to say it's the concept that biology is organised, dictated, and run by biomolecules rather than just by DNA, because one of the things that's brilliant about synthetic biology is grabbing hold of the latest technologies and just using them with a gusto and applying them to different things. Whether that's, in the early days, it was restriction digests and cloning and the PCR. Then that evolved into, we can make any piece of DNA we want synthetically. And now that's evolving, of course. We can cut and paste, chop and change, play with DNA using CRISPR and related technologies. But I think one of the things that we lose in all of this is the fact that, the DNA is there. It's an amazing molecule, but it's passed on. It's a molecule of inheritance, right? But all the molecules that did the work after that are usually other molecules. So RNA is then onto proteins. And of course, I say I'm prejudiced because I am. I love protein molecules. I think it's fascinating what they can do. So the key learning objective for me would be that, there's a whole load of other biological molecules that are involved in making biology work, and that we can manipulate. But before we can manipulate them, we have to understand them. And whereas we can understand the instructions imparted by DNA and RNA, we really don't understand the instructions imparted by proteins and other biomolecules just yet. I mean, we haven't even started looking at carbohydrates. Proteins are hard enough. So that would be my key learning objective, that there are other biomolecules out there, and they are the workhorses of biology, and they're the ones that ultimately we as synthetic biologists manipulate and try and instruct to do things in a synthetic cell or whatever.
So tell us about the piece of science equipment you've selected.
Do you know what? I'm going to be really boring, and I'm going to ask for a flashy microscope.
And why have you picked this one?
Well, because I'm not a biologist, I'm a chemist, right? But I was thinking a bit about this, and all the chemical things I could ask for, mass specs, NMRs, X-ray machines, that kind of stuff, that would help me. They wouldn't really help me on this island, whereas a good old-fashioned microscope. And I'm going to really break the rules a little bit now and say, well, another part of that, which goes with my luxury item as well, and I'll explain why in a minute, is an infinite supply of pencils and paper. Because what I'd like to be able to do is look at what's around me, stick it under my microscope, and extract its DNA, if I like, with the bento kit and everything. But just be able to look at it first and draw pictures of it. Good old-fashioned biology. Even though I'm not a biologist, I'm a chemist.
Your group is interested in the challenge of rational protein design and how this can be applied in synthetic biology, with a particular emphasis on making completely new protein structures and functions. Can you tell us a bit more about this?
Yeah, so I got into this years ago as a graduate student because I was working on a problem called the protein folding problem. I've just alluded to that. This is the idea that protein molecules do a whole lot of stuff, a whole lot of fancy stuff in biology. And they also, from an aesthetic point of view, they look amazing. They fold up into these weird and wonderful three-dimensional shapes. And four dimensions, if you think about their dynamics and how they change with time. So I think they're just fascinating molecules. And whilst I believe I'm not that arrogant to think that they really understand these and I can design them all from first principles, because natural proteins are amazing things. I feel that one of the best ways to try and understand them is to try and design them. So we don't understand how the sequence of a protein leads to its structure and its function. So one of the tests of this is to try and design proteins de novo from first principles ourselves and try and tell protein chains how to fold up and function. And that's what my lab does. Now, there are two ways of doing this. Well, there are multiple ways of doing it. But one of the approaches that's been taken is to mimic biology. The exciting thing for me, and this is, I think, a laudable goal in synthetic biology, is to go beyond what biology has shown us. So protein designers now, particularly my lab, rather than trying to mimic natural proteins, are trying to make brand new proteins that nature has never shown us. And that's called the dark matter of protein space. So with analogy to dark matter in the universe, right? So we know it's out there, it's possible, but we just don't know what it looks like. So we're trying to design those.
And do these have any application?
Yeah, so we've in doing this, we've discovered one set of proteins that are bundles of helices, but rather than having a very cemented solid structure, which we call a hydrophobic core, they assemble around cavities. So they're like cylinders. In fact, we call them alpha helical barrels. And it turns out that nature does use these, but it only uses these very rarely. They're not very common. So we found some computational experimental methods that allow us to get into these protein barrels. Now, the good thing about a barrel, when you start thinking about it as a chemist, is that if you can control the size of the cavity in the barrel and the chemistry, you can start doing all weird and wonderful things. So the latest things that we've done with these barrels that we've invented or discovered and then invented more of, is we put catalytic activity inside the barrels. And we find that when we do that, the catalysis works much better than if you just put the catalytic residues together on a flimsy single piece of protein chain. It doesn't work then. But if you wrap this chain up into a barrel and put the active residues inside the barrel, it works beautifully. And the other thing we can do is we can bind different molecules into the center of this cavity. So we think we're finding ways into very rudimentary ways of not only mimicking biology, but also going past what biology has shown us. These are very rudimentary proteins, but they kind of work.
So what's been the highlight of your whole career?
Oh my gosh. I'm going to be really soppy about it. I could say, well, I won a prize or two, but the really cool thing for me is always working with sort of young, bright, sort of creative people. That's my real highlight. It's, especially since moving to Bristol. I had some great students before, but the students here have just been amazing. So I think it's been working with them and seeing their bright, plastic and agile minds, which are far better than mine.
So tell us about the book you've chosen.
Well, that's a great question and a hard one, because there's lots of things I'd like to take with me and read, but I've chosen the complete works of George Orwell, because there's a bit of humour and fun in there. There's a lot of satire. There's a lot of inventiveness. Some of it might make me a bit depressed, but I just think he writes so brilliantly and so thoughtfully that I think that would be my choice.
So let's have some more music. Tell us about your second song choice.
Okay, and this is no reflection on what my life's like, but I just love the song, and it's Under Pressure by Queen and David Bowie.
And why have you chosen this one?
Well, I like Queen quite a lot. and I often find myself humming their tunes, but I absolutely love David Bowie. And, you know, I could have easily chosen as my first and favourite track, because it probably is one of my favourite tracks. It Changes, or Queen Bitch, or something from Hunky Dory, which is probably the best album ever written, in my view. Or ever made. But I just felt, I don't know, on reflection, I wanted a bit more. It's like a choice of two records isn't enough. So two bands rolled into one that I quite like, and David Bowie dying this year, it seemed like a fitting thing to have a Bowie and Queen song.
Synthetic biology is a relatively new field of research, having only emerged within the last 2 decades. What do you think has been the most important breakthrough in synthetic biology so far?
Oh my gosh. So, of course, there are technological breakthroughs. I mean, we're witnessing the CRISPR age, you know, which isn't going to be owned by synthetic biology, by the way. It's going to be owned by everybody. It's going to be like the PCR or DNA synthesis. They're going to be using it in areas that we just couldn't imagine and dream of. So that's an amazing technological advance. But I'm again going to sort of duck the question a little bit and broaden it out. I think what synthetic biology is doing for us is making us think about moving beyond the boundaries and the confines of traditional disciplines. You know, to do synthetic biology properly, you have to bring together, you have to create a synthetic biologist, right? And that synthetic biologist has to be computationally savvy nowadays. Know about molecular biology and biological problems. As I alluded to earlier, ideally know about how molecules work and what you can and can't do in terms of engineering molecules. So for me, that's the most important contribution that synthetic biology has made. It's a true interdisciplinary science, and it's extremely exciting because of that. So it's hard to choose one technological advance. I'm not going to.
And what do you see for the future of the field?
Oh, that's interesting. So we've been thinking about this a lot here at Bristol, and I think what's going to happen is that synthetic biology, like bioinformatics and maybe even nanotechnology before it, is going to become embedded in traditional disciplines. You know, I think we're going to see it taught at undergraduate level across engineering, the physical sciences, the life sciences, and that's going to happen. And I think we're going to see those students thinking, wow, you know, I can really go and work at the interface. I don't have to be constrained within my own discipline anymore, which is really exciting. And then I don't think it's going to be called synthetic biology at all. I think it's going to get embedded, and I think we're going to have broader terms like biodesign. I think we're going to be talking about how you design, engineer, and manipulate biological systems much more generally than synthetic biologists are talking about at the moment with manipulating DNA.
And do you think renaming it will enable it to be welcomed more positively by the public?
It's an interesting one. It's one we've grappled with here as well, you know, whether we do call things biodesign rather than synthetic biology, because, of course, every time you start a new name or something, people think it's just a fad and it's going to go away. Synthetic biology didn't. Bioinformatics didn't. But bioinformatics did get embedded, as I said earlier on. So I think there are going to be problems if we do start trying to rename these things. People are comfortable now with synthetic biology. We've won lots of battles in terms of its perception, both in the scientific sphere and with the public at large. So by changing it again, maybe it wouldn't be that useful. But I think, I'm just going to repeat myself now, I think this science and this ability to engineer biological molecules and systems will get embedded. And I think we need to think about what we do after that. You know, what are the grand challenges? And I'm not going to name any grand challenges at the moment because, you know, brighter and bigger people than me will think about those. But there are grand challenges at the moment. New vaccines, new ways of making drugs, antimicrobial resistance. And I think synthetic biology and biodesign will play a massive role in those.
And talking about these grand challenges, if you could create anything using synthetic biology, what would it be?
An on-off button for my teenage children.
So let's hear about the final item you've picked then, your luxury item.
Do you know what? It's linked to my pad and paper because I've snuck that one in. I want an inexhaustible supply of paper and pencils because I draw as well, very badly, but I do draw and I find it very relaxing. And so I'm not going to have that as my personal item because I've already got that snuck in. I'm going to have a fishing rod and an inexhaustible supply of line and hooks, please. And this will not only help feed me, which is really important, of course, but it will also help me while away the days because I will get bored. And it will take me back to my childhood when I was, from 11 onwards up until about 18. If I wasn't doing schoolwork, which I often wasn't, I was fishing in the Birmingham canals and reservoirs and local rivers. And I could just while away a whole day fishing in the sun with a flask of coffee and some sandwiches. So that'd be my luxury item.
So how do you think you're going to find living on our desert island?
Terrible. But with those things, I've got a load of George Orwell. I've got a couple of good tracks. I've got pen and paper, fishing rod, microscope. It won't be too bad, but I should imagine I'll last a week or two with that stuff. Get pretty bored because I love being around people. That's going to be my big problem.
So I'm going to cast you away now on our desert island. Professor Woolfson, thank you so much for talking to us today on Desert Island Science.
Thank you, Alice. It's been an absolute pleasure.